Okay, so here we go. Today we are talking about especially exponents. But I want to review first what we were talking about yesterday, which is about those big heavy-duty fractions. Why do we care? Because rational numbers can be written as a fraction. Irrationals can't. They're like pi or any square root that doesn't come out nice. Okay, that's one of the things we talked about yesterday. But rationals can be written as a fraction. So we need to know all about fractions as we're doing this class. One of the things we need to know is how to handle these. I think we talked about that yesterday, so please write that one down and slap out the answer. I bet you, and if you know what you're doing, that's a 5-second job. All right, Mr. C, in the back row, what'd you get? You got this one? All right, we'll go to somebody else. Who's got this one? Raise your hand if you know this one. Go in the corner pocket there. 4/5 is correct. Square root of 16 is 4. Square root of 25 is 5. So it's 4/5. All there is to it. This one, I gave you two ways to do it. Actually, the way I kind of focused on was the calc teacher's recommended way, which is to multiply by the common denominator. Common denominator of this is, there's a 4 and an 8, so what's a good common denominator? 8. You could use 32, but it'd be smarter to use 8. If I times by 8 here and I times by 8 here, why is it okay to do that? Because really I'm multiplying by 8 over 8, which is really what? 1. So I'm really not changing the value of this whole thing. So if I'm timesing by 8 over 1, timesing by 8 over 1, why is that good? Because now 4 goes in here once, 4 goes in here twice. 2 times 2 makes 4 on the top. And on the bottom, 8 cancels the 8. 7 over 1 is 7. The answer is 4/7. So it is a pretty slick way to get those answers. I multiplied by the common denominator. Now, next thing, if I don't want to multiply by the common denominator, the 4 and the 8, I could instead say this. Do you remember yesterday that I told you that any fraction is really a divide? And I said, I really don't like divide. What do I like better? Multiply. So I could change this to, instead of 2/4 divided by 7/8, which is what it is right now, I could change it to be 2/4 times 8/7. Yes. Now, if you like that way better, do it. It works fine. Still gets the same answer. Let me do some canceling first. 2 goes in here twice. 2 goes in here 4 times. 2 times 4 makes 8 on top. 7 times 2 makes 14 on the bottom. Oh, that's right. I can reduce more. Okay. 8 has factors of 4 times 2, and 7 times 2 makes 14. That's why the answer is 4/7. So either way works. Either way gives you 4/7, but you pick which way you want. All right? You should probably know both ways, because sometimes one way works better than the other. All right, next, let's talk about this one here. This one, I want you to factor the top and factor the bottom, make 2 sets of parentheses, and then I bet you, if you can do that part right, you'll get the answer easy peasy. Okay, I'm going to pause the video for a second while you guys factor the top and bottom on that one. All right, so this is x plus 1 and x plus 1 on the bottom. X and x, and what multiplies to make 4 but adds to make 5? 1 and 4. So plus, some things that pop up mess up my smartboard, and plus. And now, put the installing software thing. Cancel, cancel. There's my answer. Yep. Now, I know some people think, can't I cancel the x's there? Nope, you can't. So that's it. Why can't you cancel those x's? Because it's not a multiply problem. If it was x times 1 over x times 4, you would cancel those x's. But it's a plus, so you can't. All right. For Pete's sake, stop installing software. I'm moving on. Here's some even tougher ones. Take a look at this one. I just a second ago told you two ways that you could handle one of these. You could either multiply by something on the top and the bottom that'll make the denominators get fixed, or you could do the flip the bottom one over and make this into a multiply by that. If I were you in this case, I'd do that way. I'd flip the denominator over and change it to a multiply problem. Give it a shot right now. I'll warn you, the answer is it's got a lot of little parts. It doesn't like cancel everywhere and turn out to be really nice and clean. All right, so if you were paying attention on that part, you know that it's y over x squared is what I'm going to multiply by now. Oh, here's my new problem. And now on the top, hopefully you know that there's parentheses here and here. Anytime you have a fraction, there are invisible parentheses there. Now I'm going to go y times the x plus 4, and it'll be y times the x and y times the 4. Yx, or xy, times 4y, sorry, plus, over, I got to take the x squared times the y, yx squared. Could be x squared y, I can reverse those, it wouldn't matter, minus 2x squared. Messy, but right. Okay? All right. Now, I know some of you are thinking, why did I have to multiply that in? Technically, you probably could have left this as a y in front and an x squared here and not even multiplied it in. I don't know how to answer that. Some kids said, I think that's the right answer, and I didn't really know how I marked that one wrong. It's a judgment call on whether or not it's better to have this stuff factored out, like it is now, or to multiply it in. So I probably would have accepted this as an answer also. All right. Now this last one I want to work through with you because I know that one of our tougher tests, we have a problem just like this, except it's like you have a few word problems, like you're a few words to like sort through, and then you figure out, oh, the question is really asking this. And then you have to solve this, and it involves common denominators and fractions in fractions. This is pretty intense. It's on one of your tests, and I think I remember it being one of the A-level questions, meaning that if you get this one right, you have a chance of getting the A on the test. Okay, so you do need to know how to do this. Now, it's really intimidating because it's got so many little parts, so you break it down and just take one piece at a time. I'm going to take this piece and see if I can do that. Is that add, subtract, multiply, or dividing fractions? Subtracting. You can only subtract fractions if you have a common denominator. Does it have a common denominator? No. Can I get it so it does have a common denominator? Yes. So what is the denominator on the x? There's a 1 down there. So it's really x over 1 minus 3 over x minus 2. All right, so all I've established is that I can put a 1 underneath the x. But what can I do to get them to have common denominators? I can multiply on the top and the bottom by something. So I'm going to choose to multiply on the top and the bottom here by x minus 2. Do you see how that's going to mean that this will have the same denominator as that? They will be the same thing then? And then I can add them, or subtract them in this case. So now, to finish this off, I'm going to do it in blue. It's going to be that minus that all over that. So it's x squared minus 2x minus 3 all over x minus 2. That's the top of my fraction, except it's been added together or subtracted after it got a common denominator. So that's just this, except it's been fixed. It's all over. Now I got to get this fixed and put it there. Okay, so how do I do that? first thing to do is to realize this is really x over 1. Okay? And then I can get a common denominator. So what should I multiply by on the top and the bottom to make that work? X. Multiply by x here and multiply by x there. How can I do that? Because that's really equal to 1. And I'll have x squared over x. Okay, we got interrupted there, but we're back at it. All right, so now I'm multiplying this thing by x over x, so that makes x squared there, and x on the bottom. X squared over x minus 5 over x. Do they have a common denominator? Yes, they do. Now I can actually add them together, or subtract them. So what I get is x squared minus 5 on top, all over x. X squared minus 5 all over x. All that work, and all I've got now is at least they have a common denominator on top and the bottom. And I still have to do more from there. Now I can do that thing where I flip the bottom one. I take this guy down here and I flip him over and I multiply it by the top one. And I don't want to do all of the rest of that with you because it just takes too much time. But I think from there, you get the idea. You can do that flip and multiply deal. All right? It's just hardcore algebra. All right. I don't think we need to do any more of those. Let's talk about the stuff that's fresh here, the new stuff for today, and it's mostly about exponents and powers and that kind of stuff. Now, if you have something like this where it's a with a little root and a little 3, that means the cube root, and hopefully that's familiar with you, to you. You probably, though, didn't learn what the names of these things were, but you learn them now. That's called the index. This is called a radical, this actual sign here. And the last part is the radicand, and that's the thing that's underneath the radical sign. Okay? Now, square roots I know you were familiar with. If I said square root of 25, you would simply say what? 5. Square root of 25 is 5. But did you know there was a little 2 there the whole time? There's always been a little 2 there that you don't see. If you don't see it, it means that the teacher was just kind of doing the that's sort of like the default. If I write that, it means there's a 2 there. All right. But if I put a 3 there, that doesn't mean square root. It means cubed root. And a better example would be to use would be like 8, because that has a cubed root. What is the cube root of 8? 2. Because it means what times what times what makes 8. 2 times 2 times 2 makes 8. All right. So cube roots are like that. If I wanted to give you a few to memorize, I'd say you should know the cube root of 8. You should also know the cube root of 125. That one comes up a lot. Can you think of what times what times what makes 125? 5. Good. Another one to memorize would be the one that comes out with an answer of 4. Can you figure out what that one must be? 64. The 64 is what you get when you go 4 times 4, which is 16 times 4. And then the last one I'll have you memorize is the one that comes out with an answer of 3. Think about that. What times what times what? 3 times 3 times 3, 27. Cube root of 27 is 3. All right, so make sure you know those, because those have to be like easy. All right, so let's do a couple practice problems. This is square root of 49. 7, yay, an easy problem. Square or cube root of 125. 5. The square root of 9/16. Square root of 9 is 3. Square root of 16 is 4. 3/4. The next one. Wait a minute, there's a negative out front. But if it didn't have that negative, it would just be 4, right? So what's the answer? -4. And last is, wait a minute, the negative's underneath the root. That's a no-no. You're not supposed to do that unless you use what kind of numbers? I is the imaginary. So the final answer would normally have been 5. So what do you say? 5i. Really what you're doing there is you're saying that the square root of 25 is being broken up into 2 parts. It's being broken up into square root of 25 and the square root of -1. And that's 5, and that's I. Let me show you a little bit more about that. If I said the square root of 200, you should be able to say, oh, well, that could be broken up into square root of 100, which you know, and the square root of 2, which would be 10 root 2. Do you remember doing that sum in your past? All right, good. So then if you got that, would you please figure out for me what the square root of 50 is? Write one down in your notes, just as a reminder for yourself. You got to know this kind. So that could break into two roots, root 25 and root 2. Yeah, that's 5, so it's 5 root 2. Raise your hand if you had that one right. All right, good. Moving on. In these problems, I bet you already know which one the power and the base and the exponent. Wait a minute, there's two words for exponents there, kind of. The base is the 10, but I bet a lot of you would have sort of thought these are kind of interchangeable up here. I usually used those, but if you really want to be technical about it, which one do you think is more correct? The what? Exponent or power? Exponent. This whole thing is a power. Okay? The whole problem is a power. All right, moving on. Properties of exponents. You have to be able to handle, this is like has so many letters on it, just makes my head swim just looking at it. So I want to break these down into simpler ones for you. When you see a problem that's got exponents that are being either added or subtracted or multiplied or whatever, something like this, b squared times b to the third. Well, the answer is either b to the fifth or it's b to the sixth. I know you learned this before, but I know a lot of kids will forget which one it is. Now, here's the thing. I'm not real big on just memorize this. Sometimes there's things you just have to memorize. But I'd really rather have you be able to think it out. Like b squared. That's like this, isn't it? And b cubed, what's that like? B times b times b. And then if there's a times in between them, it's like this. Now you can look at that, and I bet you anything you'll know after reminding yourself by doing that, oh, it's got to be b to the fifth. It can't be b to the sixth. There's only 5 b's there, right? It wouldn't make any sense. So this is b to the fifth. So when they're like this, you add them. When they're like this, you don't add them. So what do you think the answer is? B to the sixth. Could you work this out? Yes, you could. B squared to the third means b squared times b squared times b squared. And I challenge you to look at that and then think that the answer is b to the fifth. Wouldn't make any sense, would it? B to the sixth, it becomes obvious it must be that. And so it must be a multiply. All right? So when they're like this, you multiply the powers. How about if they're like this? 2b to the fifth, and the whole thing is squared. It's kind of like the distributive power. Anytime you see parentheses like that, you should be thinking, oh, it's this one goes to this one, and this one also has to go to that one. And so the answer would be 2 to the second, which would be 4, b to the 10th. Again, if you had to work it out, you could say, oh, squared, that means times itself. 2b to the fifth times 2b to the fifth. And that should make it easier to see that the answer is 4b to the 10th. Okay? All right. Next kind. 10 to the fifth over 10 to the second. 10 to the third. If you had to think it out, you'd say 10 to the fifth means 10 times 10 times 10 times 10 times 10. All over 10 to the second. 10 times 10. Cancel, 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 cancel. The answer is 10 times 10 times 10, which is 10 to the third. All right. But weird things sometimes happen when you do that. What if you have b to the second over b to the seventh, and you subtract them, top one minus the bottom one, what do you get? B to the negative fifth. Is that right? Yes, it is. And as far as what does it really mean, what's b squared really mean? B times b. What does b to the 7th mean? A whole bunch of b's. Cancel, 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 cancel. And this is important to know where if you're canceling, you really have ones, right? So it's 1 over b, 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 b. 1 over b to the 5th. That means that our first answer of b to the negative 5th is really equal to 1 over b to the 5th. Do you remember that about negative exponents? Like they just flip the other thing and they put 1 over it? All right, so if I have 5 squared, I hope you know that that's 25. But what's 5 to the negative 7? 1 over. All right, on your paper right now, please do this one. 6 to the negative 2nd. Just write down the answer. I need to get you involved in actually writing because if you're just watching, it involves a different part of the brain. If you get a different part of the brain involved, you're going to increase retention. So I need you to keep your pencil moving. All right, so this is just like 6 squared should be 36, except what? It's 1 over. All right, last thing is when, not last thing, second to last thing. If you have problems like this, 3a to the, I'll just say 3a, b to the negative 2nd, all over 2a to the negative 1st, you got to know how to flip something when it's in the middle of a fraction. How do I flip or put 1 over just this part right here? What do I do to it? I move it to the other spot. I move it like down here. And this guy, how do I flip it? I move it up to the top. And this would become 3a with another a to be 3a squared. And then this b goes down here, and so I'd have 2b squared, except the negative falls off. It's just 2b squared. All right. Now, another way I sometimes describe these problems, my dad lives in a condo down in Florida. It's a true story. And some people are negative about living in the lower level condos. He's got a lower level one. And some people are negative about living in the upper level condos. There's advantages to both. And some people are in the lower level condos and really wish they were up high. And there's other people that are in the higher level condos and really wish they were down low. And they're old people and they've retired and they got nothing else better to do. So they think about these things. And I swear I've talked to my dad about this like 5 times. That oh, there's advantages to being on the upper floor, or there's a lot of advantages to being on the lower floor. So well, I bet you guys can even think of some. What's an advantage to being on the upper floor? You can see better. Good. What else? What if you're worried about safety? True. Don't get flooded on the upper floor. Good point. That actually happened at their condo. Got flooded in the lower floor. Upper floors are fine. What else is good about up? Safety. You probably don't think about this too much, but just in Chaska the other day, they had some crazy person breaking in to, like, did you hear about this? 7-year-old. There was a scary guy. Opened up the window, climbed in the room with the 7-year-old. This is in Chaska, and then escaped out the same window. And then so all these mothers that I know that were talking to math office were like, yeah, and it was funny. Right after the news show aired, I ran around and I was locking all the windows, and I looked out the window. My neighbor had watched the same show and was locking all their windows because they were all worried like the crazy Chaska guy's going to come climb in the window. So anyway, the lower level is not as safe because people can climb in your windows and stuff and see in the lower level really easy. If you're on the upper level, harder to get in there. Not like it's impossible, but it's way easier for the bad guys to get you if you're on the lower level. All right, so anyway, there's reasons to be on the upper level. The lower level's better, though, for people that are old, like a lot of senior citizens are, and have like bad knees or bad hips. My dad's got a bad hip. So when he walks, he uses a cane, and he does not like stairs at all because it hurts his hip. So for him, the lower level's great. I'm so glad I'm not on that upper level because of the hip. So there's people that are complaining about either they are on the top, wish they were on the bottom, or vice versa. Think of these people as the people who are being negative about being there on the bottom level condo, and they want to go up. And these people are negative about being on the top level, and they want to go down. And so the end result would be the 4a squared stays the same. They're all happy where they were. And the 7 was fine where it was, and the b was fine where it was. But these a's need to go up and join those a's. So there was 2 up there, and now there's going to be 5 more, so it's going to be a to the 7th. And the b's go down, and there's 3 of them, and they're going to join up with the other b down in the basement. So then there's going to be 7b to the 4th. Once you've got it so there's no more negative people, everybody's happy, and you got the right answer. All right, last thought. I know you know how to do this. X plus 2, x minus 3. That's the FOIL thing. First, outside, inside, last, right? But what if the problem is written like this? Some people just get this dumb thing in their head and go, oh, well, that's just x squared plus 2 squared. No, it's not. Think about what x plus 2 squared really means. X plus 2 times x plus 2. And that's going to be one of those first outside, inside, last problems. The answer is not x squared plus 2x. Why? Because this is a plus problem. You can't just distribute that 2 out. It doesn't work. You got to stretch it out into one of these and then do first outside, inside, last. All right. And the last thought is, what happens if you're doing this, except the other thing you're going to multiply by has 3 parts? X squared plus 2x plus 7. Then, if I had just said to times it by 2, that'd be easy. I'd take the 2 times this, and the 2 times that, and the 2 times the 7. I'd just do 2 times each part. So it's really the same thing. It's just that the 2 needs to get times by everything. But so does the x. That needs to get times by everything. And once you write down all 6 parts and you add them all together, then you've got your right answer. I call this the giant clam technique. See how it looks sort of like a giant clam from the side? Like it could crack open like right along here. And when the giant clams in some places are deadly, because people will go down either with oxygen tanks, or even if they were snorkeling where they don't have any oxygen available, and they would touch the giant clam, and what happens? It doesn't like jump and like try to eat you really, but it tries to protect itself, and so what does it do? It shuts. Put your hands in there. Now all of a sudden, you got like an 80-pound, almost like a rock, that's kind of cemented to the bottom of the ocean, and your hand's stuck in it. So even if you got a tank full of oxygen, it's going to eventually run out. Exactly. You'd have to cut your hand off or something. And then, of course, you got blood in the water, and that's not good either, because then the sharks can come after you. But anyway, it's a lose-lose situation. Okay, so anyway, use the giant clam technique. Just don't get your hand stuck in there. All right. That's all I got for you today. We got some homework to do. So here it comes.